The given question is 11 raised to the power of x minus 11 raised to the power of 9, that is equal to 110. X plus y equal to 3. We need to find x and y values here. So what they given two equations and they ask find the x and y values. For that what we have to do, observe the second equation, what we have, x plus y equal to 3. But in the first equation, which is 11 raised to the power of x minus 11 raised to the power of 5, if we convert in the power as x plus y, then we can write this x plus y as 3, isn't it? So that's why here what you have to do, you have to multiply both sides by 11 raised to the power of x. Then we are going to get 11 raised to the power of x times 11 raised to the power of x. So that is 11 raised to the power of x times x minus, and here 11 raised to the power of x times 11 raised to the power of 5. When bases are same, we can add the exponents. So after using that property, this become 11 raised to the power of x plus y. For x plus y, using the second equation, we can write this as 3. So that is equal to 110 times 11 raised to the power of x. Now observe this, 11 raised to the power of x times 11 raised to the power of x minus 11 raised to the power of 3, that is equal to 110 times 11 raised to the power of x. It is a bit complex to solve. That's why in the left hand side we have 11 raised to the power of x terms, and right hand side also we have 11 raised to the power of x term. So that's why let us consider 11 raised to the power of x as some variable a. Then this equation turns into a times a, which is a power 2 minus 11 raised to the power of 3, that is equal to 110 times 11 raised to the power of x. That is, we consider this as a, just write a. So this we can write as a raised to the power of 2 minus 110a minus 11 raised to the power of 3, that is equal to 0. So what is 11 raised to the power of 3 value? 11 raised to the power of 3, we can write this as 11 times 11 times 11. First we do 11 times 11, so which is 121. We know that 11 times 11, the result is 121. Still we need to do times 11 to multiply by 11. Shortcut is, first you have to write the first and the last number as your first and last, and then you have to add from right hand side to left hand side two numbers. So 1 plus 2, which gives 3. So just write 3 here, and then again you have to start from 2 and another next two numbers from right to left. So 2 plus 1, which is 3. That's it. 121 times 11, the result is 1331. So 1331, that is equal to 0. 1331, it is a product of 121 times 11. So if you do subtraction this 121 and 11, we are going to get minus 110. So that's why let's write, instead of minus 110, you can write this as minus 121a plus 11a minus this 1331, we can write as a product as 121 times 11, that is equal to 0. From these two terms, if you take it a as common, then we are going to left a minus 121. From these two terms, if you consider 11 as common, then you can left a minus 121. So from here we can say that a plus 11 equal to 0 and a minus 121 equal to 0. So a is minus 11 and here a is 121. We consider 11 raised to the power of x as a. So let's take that. So 11 raised to the power of x is minus 11. 11 raised to the power of x equal to, so 121 is nothing but 11 raised to the power of 2. When bases are same, we can equate the powers. From here we can say that x as 2. So we can find x as 2, and we need to find only this 11 raised to the power of x equal to minus 11. So here we have a negative form. So that's why let's recall the Euler's identity. So what's the Euler's identity? E raised to the power of ix, that is equal to cos x plus I sin x. If you take x as pi, then that is going to be e raised to the power of I pi, that is equal to cos pi plus I sin pi. So cos pi, the value is minus 1 plus I times sin pi, the value is 0. So this is going to be 0. So the e power I pi, the value is minus 1. So here we have a minus 11. So this minus 11 we can write it as minus 1 times 11, isn't it? So now here instead of this minus 1, we can introduce this Euler's identity, e raised to the power of I pi. So this is e raised to the power of I pi times 11, that is your 11 raised to the power of x. So now x is in the exponent. So what you have to do? Take natural log on both sides. So now it is in the form of ln of a raised to the power of m. We can write this as m times ln a. So we can write this as x times ln 11, that is equal to, in the right hand side it is the form of ln ab. It is a product form. We can write this as a ln a plus ln b. We can write this as ln of e raised to the power of I pi plus ln 11. So this also it is in the form of ln of a raised to the power of m. We can write this as m times ln a. So we can write this as I times ln e raised to the power of pi. Now observe these two are opposite functions. So after getting cancelled, we left only pi. So here we are getting only pi. So I pi plus log 11. So we need to find x value. So that's why both sides divide by log 11. So after getting cancelled, we are going to get x equal to, so the right hand side, this we can write it as I pi over ln 11, that means log 11 plus log 11 over log 11. Here gets cancelled, left only 1. Our x value is 1 plus I pi over log 11. So this is the another x value. So this x value, you are getting complex numbers, but in the given equation x and y are real numbers. That's why this we are not considering. So what we left only x is 2. We need to find y value also. If x is 2, this x value substitute in the second equation, so which is x plus y equal to 3. So we got x as 2, so let's substitute in the second equation. Then y equal to 3 minus x, that is 3 minus 2, which gives only 1. So the y value is 1. So now substitute in the first equation, which is 11 raised to the power of x minus 11 raised to the power of y, that is equal to, our x value is 2 and y value is 1, so which is only 11. So 11 raised to the power of 2, the value is 121 minus 11, which gives only 110. So that means is 2 and y is 1, satisfy our given equation. These are x and y values. I hope you like this content. If you like this content, please subscribe to my channel. Thank you for watching.